Hi everyone. I wanted to clarify one thing in terms of the basic trigonometry that you did this week, and that is how angles of elevation and depression work. You have to be able to label these angles correctly to then be able to do your trig calculations correctly. So to demonstrate this, I'm going to use the example of an airplane flying towards an airport. So here's my plane, okay? And trust me, that's better than me trying to draw the plane. And then let's just say this is the airport down here. And we've got the plane approaching the airport, coming in for landing, okay? This, of course, down here is the ground. And I'll start with the angle of elevation. So let's suppose there's a person standing on the ground down near the airport. Sorry, really thick marker, so it's hard to see where that person is. And they are going to look up at the plane. So when they first walk out the doors of the airport, they're looking straight ahead, right? Their sight line is horizontal. And then when they turn their head to look up at the plane, their sight line changes to here. Whoops, well, you get the idea. This angle here that they're turning their head at, that's the angle of elevation. So you always think of it as from a horizontal line, if you're looking straight ahead and you turn your head upward, that angle that you're actually turning your head, that's the angle of elevation. Okay, so it's always measured from a horizontal line. So this angle is elevation. And that one people usually get okay. The one place where people tend to make a mistake with that one, and let me just draw another quick picture here, is I think there's one on the homework that has to do with a flag. And the sun is up here somewhere. I didn't leave myself much room for the sun. And then there's a shadow of the flag on the ground. And then it says, calculate the angle of elevation of the sun. So if the sun is casting its light down this way to the end of the shadow, the angle of elevation is always going to be from the ground upward. Like if you were on the ground and you turned your head to look up at the sun, which we don't recommend, this here would be your angle of elevation. So angle of elevation is always from the ground turning upward. Okay, let's go back to our plane here, and we're going to talk angle of depression, or in this case, it would be angle of descent. Here's what tends to happen in these problems is we get a diagram like this drawn, and I say, find the angle of descent for this plane. What angle does the plane need to descend at to reach the airport? And a lot of the times we also know how high the airplane is, so we might have, this measurement given to us. And seeing that we have a triangle right here, it is really, really tempting to jump in here and say this is your angle of depression or descent, okay? That's not the angle of descent. The angle of descent is supposed to be the way that your plane is actually turning. So if you tell me that that's your angle of descent, that means your plane has been driving like this the entire time and then suddenly takes a sharp turn and flies straight toward the ground, okay? That is not how airplanes work. And realistically, in a plane, an angle like that would be like 88 or 89 degrees. Can you picture a plane turning at an 88-degree angle? I hope not. It would be terrifying. Okay? So the angle of descent, you have to kind of visualize the path that the plane was flying on originally. Originally, the plane was flying on this straight horizontal path, right? And the angle of descent is the angle that the plane is actually turning on. So this angle here would be the angle of descent or depression. Now, my picture is very out of whack here because this angle is usually very, very tiny, but the fact that I'm using a pretty big plane, compared to the airport, it's not making my picture work out too well. But this is the angle of descent or depression, okay? And again, just like elevation, you'll notice that it started from a horizontal line. So both of these angles always start from a horizontal line and then measure how far you turn to get to the diagonal. They don't start at a diagonal and then turn vertical, okay? So descent is always up here, elevation is always here. And by the way, these two angles are always going to be congruent to each other. Because they are alternate interior angles, if you remember that from geometry, okay? So Angle of descent, horizontal line turning downward. Angle of elevation, horizontal line turning upward. And these two angles are kind of interchangeable because the value of them is going to be exactly the same. Okay, I hope that helped clarify things with angle of elevation, angle of depression, and I hope the rest of trigonometry went well. Let me know if you have questions.